Let me tell you something that most people find genuinely hard to believe the first time they hear it. There is a Toyota Land Cruiser in Australia, a working vehicle, not a museum piece, that has crossed 1 million kilometers on its original engine, not rebuilt, not replaced. The original engine, the one that came from the factory, still turning over, still pulling load, still doing its job. And if you know anything about engines, you know that 1 million kilometers is not just impressive. It is in a completely different category from everything most people think is possible. That's like driving to the moon and back, and then to the moon again, on one engine. And when people hear that, their first instinct is to say, well, it must be a Toyota, of course. They make them different. And yes, there's truth in that. But the full story is so much more interesting and so much more useful to you than just saying it's a good brand. Because the real reason that engine hit 1 million kilometers is sitting right between your ears, not under someone else's bonnet. The question I want to answer today, and I want to answer it properly, not with the usual generic advice you've heard 100 times, is what actually separates the cars that reach 1 million kilometers from the ones that barely make it past 150,000 before the engine is worn out and tired. And I promise you, by the time we're done, you are going to look at the way you treat your own car completely differently. Because what mechanics who have been doing this work for decades understand, and what most drivers never get told, is that engine longevity at that level, 500,000, 700,000, 1 million kilometers, is not an accident. It is a result of specific habits practiced consistently over a very long time. And the fascinating thing is that most of those habits are not expensive, not complicated, and not even particularly time-consuming. They're just uncommon. So let's start by understanding why Japanese engines developed the reputation they have, because I think the context actually matters here. After the oil shocks of the 1970s, Japanese manufacturers faced intense pressure to build engines that were not just reliable but efficient, engines that could go longer between services, that burned cleaner, that didn't punish drivers for the realities of daily use. Toyota, Honda, Nissan, they responded by engineering to incredibly tight tolerances, by refining their metallurgy, by obsessing over the quality of every component in the valve train, the bottom end, the cooling system. The famous 1HZ diesel in the Land Cruiser, the 22R petrol engine, the F-Series, the 2JZ, these weren't accidents of engineering. They were the result of a manufacturing philosophy that asked, at every stage of design, what would it take for this engine to still be running in 30 years? But there's another side to this story that gets almost no attention in the West, and it comes from Japan's vehicle inspection culture. Japan has one of the most rigorous mandatory vehicle inspection systems in the world, the Shaken, and it applies to every registered vehicle. Every 2 years, your car goes through a comprehensive examination. Brakes, suspension, lighting, emissions, structural integrity, drivetrain, all of it gets checked against strict standards. If anything fails, you fix it before the car goes back on the road. No exceptions. Now imagine what that does to a culture of car ownership over 50 or 60 years. It creates a population of drivers who are almost by default proactive, who fix things when they're small, who maintain their cars not because they want to, but because the system requires it. And over time, that requirement becomes instinct. It becomes the way you own a car. And that instinct, exported through the used car market, through imported vehicles, through the habits of mechanics trained in that tradition, is a big part of why Japanese cars, with service histories from Japan, so often run so extraordinarily well. Now, the mechanics I want to talk about, the ones who've seen engines at 400,000, 600,000, even 800,000 kilometers, they will tell you without hesitation that the single most important factor is oil, not the brand of oil, not whether it's synthetic or conventional, not the additive package. The factor is this: how often was it changed, and was it ever, even once, allowed to get truly dirty? Because engine oil is not just a lubricant. That's the simplest thing it does. It's also a coolant for the lower end of the engine, the bearings, the crankshaft journals, the connecting rods, areas that the water jacket doesn't reach. It's a cleaning agent carrying combustion byproducts and microscopic metal particles to the filter. And it's a chemical buffer, neutralizing the acids that form as a natural result of combustion. As oil ages, all three of those functions degrade. The viscosity changes, the detergent package depletes, the acid neutralizing capacity disappears. And once that happens, you are running your engine on fluid that is slowly working against it rather than for it. The engines that reach 1 million kilometers have almost universally been changed on a schedule that is more frequent than the manufacturer's maximum recommendation, not less. Here's why that distinction matters. The manufacturer's service interval is designed around the worst-case scenario for that oil, the maximum number of kilometers you can put on it before it becomes genuinely harmful. It is not the optimum. It is the boundary. The drivers and fleet operators who get extraordinary mileage out of their engines treat oil changes the way a surgeon treats hand washing. not as an occasional obligation, but as a non-negotiable routine. Some of the most legendary high-mileage vehicles in commercial fleets get their oil changed every 5,000 kilometers without exception, regardless of what the sticker on the windshield says, and their engines, decade after decade, remain clean inside. There is a term in engine rebuilding. You hear it when a mechanic opens up a high-mileage engine that's been well cared for. And the term is like new inside. It sounds impossible, but it's real. When oil has been changed consistently and the engine has been operated within its design parameters, the cylinder walls retain their original honing marks. The bearing surfaces show minimal wear. The camshaft lobes are crisp and undamaged. The engine, despite its age, looks like it was assembled last week. Contrast that with an engine that's been run on extended intervals, or that suffered even 1 or 2 episodes of critically low oil, and the difference is stark. Scoring on the cylinder walls, worn bearing surfaces, sludge in the oil galleries blocking flow to the top end. This is not a story about bad luck. This is a story about what happens when the lubricating film that protects precision metal components is repeatedly compromised. Let's talk about heat, because this is something most drivers never think about, and it is absolutely central to why some engines last and others don't. Engines are designed to operate within a very specific temperature range. Too cold and combustion is inefficient, fuel washes down the cylinder walls, acids accumulate faster. Too hot and the metal expands beyond its tolerances. Oil breaks down more rapidly, gaskets fail, seals harden and crack. The cooling system is not an afterthought. It is one of the most critical systems in the entire vehicle, and it is one of the most consistently neglected. Coolant degrades over time. It becomes acidic. Old, acidic coolant attacks the aluminum components in modern engines, the cylinder head, the intake manifold, the water pump housing. From the inside, you never see this happening. There's no warning light for internal corrosion, but the damage accumulates steadily, and one day a water pump fails prematurely, or a heater core develops a leak, or worse, a head gasket fails because the aluminum head has been slowly compromised for years. The mechanics who work on high-mileage vehicles will tell you that the engines, which make it to extraordinary distances, almost always have clean, properly maintained cooling systems. Coolant that has been flushed on schedule, typically every 2 to 3 years regardless of mileage, stays pH neutral, keeps its corrosion inhibitors active, and protects every surface it touches. It costs almost nothing compared to what it protects. And yet, it is one of the most commonly overlooked services in routine maintenance. People know to change their oil. Most people don't think twice about their coolant until something goes wrong. By then, the damage is already done. Now I want to spend some time on something that doesn't get nearly enough attention, and that's the way you drive your car in the first few minutes after starting it. Because this is where an enormous amount of cumulative engine wear happens, and most people have no idea it's occurring. When an engine sits overnight, or even for a few hours, the oil drains down into the sump. The oil film that was protecting every moving surface thins out or disappears entirely from the upper parts of the engine, the camshafts, the rocker arms, the valve guides. When you start the engine, there is a period. It might be 5 seconds, it might be 30 seconds, depending on the temperature and the condition of the oil, where oil pressure is building and the pump is pushing oil back up through the galleries to reach those components. During that window, there is metal-to-metal contact happening at the top of your engine. Now imagine accelerating hard during that window, revving the engine aggressively before oil has reached the camshaft. The camshaft lobes are pressing against the followers, the valve train is working hard, and it's doing all of this with minimal lubrication. You cannot see this happening. You cannot hear it happening, not at first. But every time you do it, you're removing microscopic amounts of material from precision surfaces. The clearances open up slightly. Do it thousands of times over years of ownership, and those clearances have opened up enough that the engine begins to develop symptoms. Tappet noise, reduced compression, oil consumption, that lead people to believe the engine is simply worn out. It's not worn out. It was worn prematurely by a habit that takes 5 seconds to fix. Let the engine idle for 30 to 60 seconds before you drive, and drive gently for the first 2 or 3 minutes until everything is up to temperature. That's it. That is the entire habit. It costs nothing. It takes almost no time. And it is one of the distinguishing habits of people who get extraordinary mileage from their engines. There's a related habit that's worth talking about, and that's how you shut the engine down. This is especially relevant for turbocharged engines, but it applies broadly. When you've been driving the car hard, on a motorway, up a hill, in hot weather with the air conditioning working hard, the engine is running at elevated temperature, and the turbo, if you have one, is spinning at speeds that make it one of the most thermally stressed components in the vehicle. When you switch the engine off, oil circulation stops immediately. If the turbo is hot and spinning, it will continue to spin on its own inertia for some time after the oil supply has been cut. Without oil, the turbo bearings, which are floating on a film of pressurized oil during operation, are suddenly running dry and hot. This is how turbos cook. This is why turbo failure is so common on vehicles that aren't driven or maintained with this in mind. The solution is simple. After hard driving, let the engine idle for a minute or two before switching off. Let everything cool down gradually. Let the oil continue to circulate and carry heat away from those bearings before you cut the supply. Again, costs nothing. It takes 2 minutes. The people whose turbocharged engines are still healthy at 300,000 kilometers are almost always doing this, even if they couldn't tell you exactly why. I want to talk about the transmission because I think it deserves its own moment in this conversation. People talk endlessly about engine oil, but almost never about transmission fluid, and yet a transmission failure on a vehicle with a healthy engine is one of the most demoralizing and expensive things that can happen to a car owner. Automatic transmission fluid does not last forever. It breaks down. It loses its friction modifier properties. It gets contaminated with fine metallic particles from the normal wear of clutch packs and planetary gear sets. And as it degrades, it does its job less well. Shift quality suffers, heat builds up more rapidly, and the components inside the transmission experience more stress with every gear change. The transmissions that survive to very high mileage are the ones whose fluid has been changed regularly, kept clean, and kept at the right level. It's the same philosophy as the engine. Consistent, proactive care rather than reactive repair. Tires and wheel alignment are something that a lot of people would not associate with engine longevity, but there's a real connection. When a car is running on misaligned wheels or on tires that are significantly underinflated, there is additional rolling resistance. The engine has to work harder to maintain speed. Over tens of thousands of kilometers, an engine that is consistently operating under slightly more load than it should be is accumulating wear faster than an engine in a car with properly maintained tires and alignment. It's a small effect per kilometer, but compounded over 500,000 kilometers, it is not negligible. The people who maintain their cars comprehensively, who check tire pressure monthly, who get alignment checked when they fit new tires, who don't ignore a pull to one side, are taking load off their engine in a way they probably don't even consciously think about. But it adds up. The air filter is another one that surprises people. It seems almost too basic to matter at the level we're talking about, but a clogged air filter restricts the airflow into the engine. The engine management system compensates by adjusting fuel delivery and timing, but there are limits to how much it can compensate. A severely restricted air filter causes the engine to work harder for the power it produces, running richer in some conditions, putting more load on the throttle body and intake system. Clean, unrestricted airflow is something an engine needs throughout its entire operating range. Checking and replacing the air filter on schedule, and more frequently in dusty environments, is one of those small habits that has a cumulative protective effect that's easy to underestimate. Now, let me tell you about something that really crystallizes all of this for me. It's a pattern that shows up over and over in the stories of genuinely high-mileage vehicles. The owners of these cars, the ones that make it to 800,000 or 1 million kilometers, almost never have a dramatic story to tell. They don't have some secret product they use. They haven't done anything exotic or complicated. When you ask them what they did, they describe a routine, a boring, consistent, unremarkable routine. Oil changed on schedule. Coolant flushed every few years. Filters replaced. Belts changed before the manufacturer's deadline, not after. Fluid levels checked regularly. They paid attention when the car made an unfamiliar noise, not weeks later when the noise had gotten worse. They didn't defer service when money was tight and then double up later. They kept the schedule. Because here's what those owners understand instinctively. Deferred maintenance is not money saved. It is money borrowed at a very high interest rate. The engine will collect one way or another. There's also something to be said about the emotional relationship these owners have with their vehicles. This sounds almost philosophical for a discussion about engines, but bear with me. The people whose cars go the distance tend to actually pay attention to their cars. They notice when something feels different in the steering. They notice when fuel economy has dropped slightly. They notice when a sound appears that wasn't there last week. This awareness, this ongoing attention, means that small problems get caught early before they cascade into expensive failures. An oil leak caught as a slight seep on the garage floor is a gasket or a seal. An oil leak caught after the engine has been running low for 6 months is potentially a scored crankshaft. The same problem, radically different outcomes, separated entirely by attention. So let me bring this all together because I think there's a really clear and actionable picture here. The Japanese cars that reach 1 million kilometers are not doing it because of magic. They're doing it because they were built well and maintained perfectly. And of those two things, the maintenance is the variable that you control, the engineering you get when you buy the car. The maintenance is entirely up to you from the moment you drive it off the lot. And the habits that define that maintenance are not complicated. Change your oil more often than you think you need to. Flush your coolant on schedule. Check your transmission fluid. Replace your filters before they're clogged. Give your engine a gentle warm-up before you load it. Let it cool down before you shut it off after hard use, and pay attention, real, consistent attention, to what your car is telling you every time you drive it. That is the formula. That is the whole thing.